So our first step here is to figure out what the vertex is. It's whatever makes that parenthesis equal to 0. So in that case, it's 3. And whatever this number is with the sign, so 3, 1. It's a reflection over the x-axis, whether you answer this question or not. Is this positive or is this negative? If it's positive, it's no. If it's negative, it's yes. Our domain every single time is going to be infinity to infinity, but we'll let the graph show us that. We don't really need the chart for the first two. After that, I am going to let the graph dictate it. So we have 3, 1 as my vertex. I'm going to count down by 1. 2 and 1, 4 and 5. 4 minus 3 is 1. 1 squared is 1. 1 times 2 is 2. 2 plus 1 is 3. So if 4 is 3, so is 2. If I want to show the work, I'll put it in for 5. 5 minus 3 squared plus 1. 5 minus 3 is 2. You have to square the 2 first. So we have 8 plus 1, and that equals 9. So it's 5, 9, and 1, 9. So my graph, 3, 1, 4, 3, and 2, 3, 1, 9, and 5, 9. And that's what my graph should look like. Domain, negative infinity to infinity. Range, we're going from infinity to 1. So it's a bracket around the 1 to infinity. It increases from my vertex to the right. So from 3 on the x-axis to infinity, it increases. Therefore, it's decreasing from negative infinity to 3. It's a minimum point because it's opening upward. And the line of symmetry is always x equals the x coordinate. My vertex, what makes the parentheses equal to 0? 2. And we have the positive 8 out here. The reflection over the x-axis. Is it a negative out there? Is the a negative? Yes. So therefore the reflection is yes. So I go 2 and 8. My denominator is 3, so I'm counting by 3s. 5, 8, negative 1, negative 4. 5 minus 2 is 3. 3 squared is 9. Negative 1/3 times 9 is negative 3. Plus 8 is 5. Negative 1/3. 8 minus 2 squared plus 8. We have 6 squared plus 8. Negative 1/3 times 36 plus 8. Negative 1/3 times 36 is negative 12 plus 8. And we get negative 4. Negative 4, negative 4. And we graph those points. 2, 8. Negative 1, 5. So therefore 5, 5. 8, negative 4. Negative 4, negative 4. And there's my graph. My domain goes from negative infinity to infinity. I'm reading my range. It's going downward. So it's going to negative infinity and it's stopping at 8. So negative infinity to 8. It's increasing from negative infinity to 2. It's going up from the left side of the graph to the vertex. So it's negative infinity to 2, increasing, and then obviously it decreases from 2 to infinity. Since we're going up and then down, this is a max point. And the vertex is your max point, and the line of symmetry is x equals 2. We're always going to ask for a vertex, but in standard form, I'm not going to ask for a reflection anymore. We're going to be using negative b over 2a. My a is 2, my b is negative 8, my c is negative 1. So negative 8 over 2 times 2. We have a double negative here, so it's going to become positive. 8 over 4, and that's 2. So my x coordinate for my vertex is 2. I can put that in right away. And now I'm going to plug my 2 in for x to get my y coordinate. I'm going to deal with the exponent first. It doesn't turn into 16. We don't do 2 times 2 and then 4 squared. It's 2 squared, and then we're going to multiply that by 2. 8 minus 16 minus 1, and we get negative 9. Okay. My other 2 points, I'm going to plug 0 in for x every single time, and I'm going to get negative 1. So if I plot those 2 points, 2, negative 9, I'm right here, and 0, negative 1, I went over 2 from my line of symmetry. I went over 2, I need to go over another 2. So my other point is going to be 4, negative 1. And now I can draw my graph from those 3 points. My domain, as always, is going to be negative infinity to infinity. My range, it's going up. So we're going from negative 9 to infinity. It is decreasing as I come in from the left and increasing as I go out to the right. So it increases from 2 to infinity. And it decreases from negative infinity to 2. My max min point is going to be my vertex. It's 2, negative 9. We're literally just copying the vertex over. And my line of symmetry is x equals 2. And standard form, negative b over 2a. Okay? So we're going to have a, b, and c. Negative 12 over 2 times a negative 3. The double negative becomes positive. So this gives me another 2. It's a coincidence that it happened to be 2 twice. It's not always going to be 2. Okay? Now that gives me the x coordinate of my vertex, 2. Negative 3 times 2 squared plus 12 times 2 minus 7. Negative 3 times 4 plus 12 times 2 minus 7. Negative 12 plus 24 minus 7. Negative 12 and 24 is 12 minus 7. We get 5. So my vertex is 2, 5. That's how you get the vertex every single time in standard form. Okay. I'm going to plot 2, 5. When I plug 0 in for x, I get negative 7. So we had that 0, negative 7 point. I can put that in. It may help to put your line of symmetry down. 1, 2, 1, 2. But that other point is 4, negative 7. And that's going to allow me to draw my graph. So I go up, down, and there's my graph. And then I can answer the other questions off of that. The domain, negative infinity to infinity. The range, negative infinity to 5. It's increasing from negative infinity until we get to our vertex of a 2 point. So it's increasing from negative infinity to 2 and decreasing from 2 to infinity. You'll notice it's the same number in the increasing and decreasing both times. It's going to be that way every single time. The maximum point here, because we're opening down, is 2, 5. And my line of symmetry is x equals 2. So on this particular problem, in x-intercept form, I would find the x-intercepts first, then the vertex. So my x-intercepts are literally what make the parentheses equal to 0. 3 and negative 1. And then I'm going to take an average of my x-intercepts. And that is the x-coordinate of my vertex. So the x-coordinate of my vertex is 1. To get the y-coordinate, 2 times 1 minus 3 times 1 plus 1. 2 times negative 2 times 2 is a negative 8. And there's my vertex. 1, negative 8, and those are my points. 3, 0, negative 1, 0, and 1, negative 8. And now I'm answering those 6 questions based off the graph. My domain, negative infinity to infinity. The range is going up. So it starts at negative 8 and goes to infinity. It's increasing from the vertex going to the right. So that's 1 to infinity, therefore it's decreasing from negative infinity to 1. The minimum point, because it's opening up, is my vertex once again, and my line of symmetry is x equals 1. Okay, here my x-intercepts are going to be 4 and negative 2. Because that's what makes these zeros equal to, or these parentheses equal to 0. So the average of 4 and negative 2, 4 and negative 2 is 2, 2 over 2, we get 1. Coincidence, we got 1 again, you're not always going to get 1. So now we get negative 1 minus 4, 1 plus 2. Negative, negative 3, 3. And negative, negative 3 times 3 is a positive 9. So my vertex is 1, 9. And now I'm going to graph those points. 1, 2, 3, 4. Negative 2, 0. And we get 1, 9. Graph down. Graph down. My domain, negative infinity to infinity. Since the graph is going down, the range, negative infinity to 9. We are increasing from the left to the right. Negative infinity to 1. And we're increasing from negative infinity to 1. And we're decreasing from 1 to infinity. Once again, it is a maximum point because I'm opening down. And the maximum point is your vertex. And the line of symmetry is x equals 1.